Hello, so my project is a self-balancing robot. A self-balancing robot has been constructed with the help of an Arduino Uno, which is a microcontroller, as well as an IMU 6050 sensor, which is used to measure the angular displacement and the angular velocity. I've also used an L293D motor controller for controlling two 300 RPM motors, as well as a 1550 mAh LiPo battery for the power supply. So the concept of a self-balancing robot is that when you switch it on and you leave it, it is supposed to balance itself and not fall down. But in this case, right now, it's not balanced because the power is switched off. So how it works is that basically the angular displacement and the angular velocity is consistently measured by this chip right here, and those values are sent to the Arduino Uno, in which an PID algorithm, namely a proportional integral derivative algorithm or a control module, is programmed. So there are three parameters, namely in the PID algorithm, called as proportional gain, integral gain, and derivative gain. By adjusting these three parameters, we can fine tune the robot so that it is able to balance perfectly without any vibrations. But as of now, I have not reached that level. I've only I haven't fine tuned it to that level, so it is able to balance, but after a few seconds it starts to vibrate violently. So I'll now demonstrate the working of this robot. First, when it is switched on, you can see that the microcontroller is switched on. Then I will have to give an interrupt signal from the laptop by plugging in a cable. Now the interrupt signal has been given, and the program will start to run itself, and once I leave the robot in a stable position, it will be able to balance itself without falling down. But as you can see, the robot starts to vibrate after a couple of seconds because the parameters have not been finely tuned yet. But the concept seems to work, and another application of this is used in the Segway and also in the hoverboard industry, where if you give a small force on one side, it will be able to move to this side, and when you give a small force on that side, it will move to the other side.